Hello students. Hello and welcome to this video. In this video, we will solve question number 111 to 120 of binomial theorems. The link to download the PDF will be in description given below. At the end, I will show you how you can download a printed copy of the PDFs and maintain them. Also, I'll show you my question answer website where you can come and ask your mathematics questions because YouTube video is not really suitable for mathematical content. So without further ado, let's get started. Question 111 has this equation: C0 upon 1 times 2 minus C1 upon 2 times 3 plus C2 upon 3 times 4 and so on up to minus 1 to the power n Cn upon n plus 1 times n plus 2 is equal to 1 upon n plus 2. So we have this series 1 minus x to the power n is equal to C0 minus C1x plus C2x and so on, which you know. Now we integrate within limits 0 to x. So upon integration, the left hand side becomes minus of 1 minus x to the power n plus 1 upon n plus 1 plus 1 upon n plus 1, and right hand side becomes C0x minus C1 times x square upon 2 plus C2 times x cube upon 3 and so on. We integrate within limits 0 and 1 once again. We get 1 minus x to the power n plus 2 upon n plus 1 times, this should be n plus 2, plus x upon n plus 1. This is between limits 0 and 1, and right hand side becomes C0 1 times 2, this should be x square, then minus C1 upon 2 times 3, you put x is equal to 1 here, and C1 upon 2 times 3x cubed, which will also become 1, plus C2 upon 3 times 4 and so on. So right hand side is equal to left hand side, and upon evaluating the limit, it becomes equal to 1 upon n plus 2. Question 112 says that the given equation is C0 upon 2 minus C1 upon 3 plus C2 upon 4 and so on up to minus 1 to the power Cn upon n plus 2 is equal to 1 upon n plus 1 times n plus 2. So we know that 1 minus x to the power n is equal to this series that we already know. We multiply by x, we get C0x minus C1x square plus C2x cube and so on. Integrate within limits 0 and 1. It becomes x times 1 minus x to the power n plus 1 upon n plus 1 plus sign of integration limits between 0 to 1. 1 minus x to the power n plus 1 upon n plus 1 dx. And our right hand side, we put x is equal to 1, it becomes, no, we don't put x is equal to 1, we put limits 0 and 1, it becomes C0 upon 1 times 2 minus C1 upon 2 times 3 and so on. So we integrate this equation, we get minus 1 minus x to the power n plus 2 upon n plus 1 times n plus 2. So we put the limits of 0 and 1, we get the required equation. Question 13 says that we have to prove that the equation is C0 upon 3 minus C1 upon 4 plus C2 upon, this should be 5, and so on up to Cn minus 1 to the power n Cn upon n plus 3 is equal to 2 upon n plus 1 times n plus 2 times n plus 3. So similar question, we write 1 minus x to the power n multiply by x square and then we integrate. Okay, this time integration is more complicated, but it's the same thing. So if you see this left hand side over here, it is the required stuff on the left hand side, and you integrate, the integration is given below, it will eventually become 2 upon n plus 1 times n plus 2 times n plus 3. Question 114 says that we have to prove that 3 times C0 plus 3 square times C1 upon 2 plus 3 cube upon C2 plus 3 and so on up to 3 to the power n plus 1 Cn upon n plus 1 is equal to 4 to the power n plus 1 minus 1 upon n plus 1. So we know that 1 plus x to the power n is equal to C0 plus C1x plus C2x up to C2x square plus up to Cnx to the power n. We integrate within limits 0 and 3 and you will have the desired result. Question 115 says that if n is a positive integer in 1 plus x to the power n, show that 2 times n factorial upon 2 whole square upon n factorial multiplied by c0 square minus 2c1 square plus 3c2 square and so on up to minus 1 to the power n plus 1 cn square is equal to minus 1 to the power n by 2 times 2 plus n. So we know that 1 minus x to the power n is equal to this series. We multiply by x to get this. Now we differentiate both sides with respect to x. We get 1 minus x to the power n minus nx, 1 minus x to the power n minus 1. And right hand side becomes c0 minus 2c1x plus 3c2x square and so on. We also know that x plus 1 to the power n is equal to c0 xn plus c1 x to the power n minus 1 plus c2 x to the power n minus 2 and so on up to cn. We multiply these equations, this and this, and we get 1 minus x square to the power n minus nx 1 plus x times 1 minus x square to the power n minus 1, and right hand side is the multiple of two different expressions. Now we equate the quotient of x to the power n. The right hand side becomes left hand side, and it is c0 square minus 2 c1 square plus 3 c2 square and so on up to minus 1 to the power n plus 1 cn square. And the quotient on the left hand side now comes to right hand side, which is equal to minus 1 to the power half, or rather n by 2 it should be, c n by 2 times n c n minus 1 upon n upon 2 minus 1. Now we evaluate this, and it is equal to minus 1 to the power n by 2 times 2 plus n. Question 116 says that show that sigma 0 less than equal to I less than equal to n, sigma I less than j less than equal to n ci cj is equal to 2 to the power 2n minus 1 minus 2n factorial upon 2 times n factorial squared. So we have this equation ci cj. This we can write as c0 plus c1 plus c2 up to cn whole square minus c0 square plus c1 square plus c2 square and so on up to cn square. This we already know, both the series, that this c0 plus c1 plus c2 up to cn is equal to 2 to the power n, and the square term, yeah, where is that? There is something wrong here. Looks like there is some typing mistake. 2 to the power n minus, this should be 2ncn. This is equal to 2ncn. We will figure out this very quickly, okay? Let's take c0 square plus c1 square plus c2 square. We look up. There would be one such series. Give me a moment. Okay, let's say we don't have the series, okay? So question 116, we figure this out. So to evaluate this, what we do is we take 1 plus x to the power n is equal to c0 plus c1 plus c2 up to cn. Okay, c1 will have the multiple of x, c2 will be x square, and c3 will be x cube, and cn will be xn. So we know the expansion of 1 plus x to the power n. Now what we do is we write it as x plus 1 to the power n. So what it becomes is c0 x to the power n plus c1 x to the power n minus 1 plus c2 x to the power n minus 2 x to the power n minus 2 and so on up to cn. Now we multiply both and take the coefficient of x to the power n. So that would be 2ncn. So yes, it is correct. It would be equal to 2ncn. So product of 1 plus x to the power n times x plus 1 to the power n, and in that you take the coefficient of x to the power n, you will have this series, and that is equal to 2ncn. So upon evaluating 2ncn, we get 2n factorial upon n factorial whole square. Now you see that this is 2 cij, okay? So 2 we divide here, and we get 2 to the power 2n minus 1 minus 2n factorial upon 2 times n factorial square. So it is not difficult to compute this as you see, I completed it verbally, but you should use pen and paper and not rely on verbal thing, because in exam, verbal calculations won't work. Question 117 says that show that, again, there is something wrong here. This was correct. So what is this? It should be sigma r is equal to 0 to n. Okay. And we'll see 117, there is some typing. If there is something, we'll look at the answer, we will know. So there is some sigma is going on here, is equal to the quotient of x to the power n, y to the power n in the expansion of 1 plus x times 1 plus y times x plus y to the power n. Okay, this looks like 3ncr or something like that. We look at the answer, we will know. So no, it is 3cr only. I is equal to 0 to n. So we write 1 plus x to the power n expansion here, 1 plus y to the power n, and x plus y to the power n here. We multiply all three and equate the quotient of x to the power n, y to the power n. Okay. Once we do that, it will be equal to 3c0 plus 3c1 plus 3c2 up to 3cn. So this is sigma r is equal to 0 to n c 3cr. That is what it is. Now, let me look at this a bit carefully. So we multiply this. Let's take the quotient of x to the power n, y to the power n. So one quotient will be C0, C0, and CNYN. Okay. So it is not actually 3CR. Okay. It is actually NCR to the power 3. And we have omitted as usual on top. It is NCR to the power 3. So here, this is C0 cube, C1 cube, C2 cube, and so on up to Cn cube. So you look at the quotient of x to the power n, y to the power n. One quotient we will take. That is C0, NC0, NCn, which is equal to NC0. So NC0 squared, and this is NC0 cube. So it is this term. Okay. So that's how we know that it is cube. It should have been little more explicitly, and there should be a sigma, there is a typing mistake here. Question 118 says that prove that sum of the quotient in the expansion of 1 plus x minus cx square to the power 2163 is minus 1. So now we are entering the multinomial territory. So we write this given expression as a0 plus a1x plus a2x square up to, there will be 6489 terms, x to the power 6489, 2163 multiplied by 3. Okay. Now we have this. This should be, again, there is something wrong. This power should not be this much. Because even if you multiply x squared 2163 times, it won't be that. This is correct. Quotient is correct. Power is not. Okay. So what we do, or whatever is the power, does not matter. You can write this as ARX to the power R. Okay. There will be some quotient. So quotients are written with the increasing power of x. I will have to fix this. This power is not good. It is not a typing mistake, it is a calculation mistake. Now we put x is equal to 1, we get sum of quotients as 1 plus 1 minus 3 to the power 2163. That is minus 1 to the power 2163 is equal to minus 1. So see, complicated questions, when you look at this kind of expression, if you look at the question, it looks very intimidating. How would you compute it? But in essence, it is very simple to solve. So sometimes questions which appear to be difficult can be very easy. For example, look at the next question. If 1 plus x minus 2x squared to the power 6 is equal to 1 plus a1x plus a2x squared plus a12x to the power 12, show that 1 plus a3 plus a6 plus a9 plus up to a12 is equal to 31. So what you need to do is you put x is equal to 1 plus omega square in the given equation, and add, you will have the desired result. Okay. You need to do it. I'll tell you how it becomes. So 1 will remain same, so it will become 1 3 times. Okay. And then you put x is equal to 1 here, then you put omega, then you put omega square. So a1 times 1 plus 1 omega plus omega square, which will be 0. So a1 will not come here. Now you take a2. So put x is equal to 1, then omega, which will become omega square, and then omega square, which will become omega 4, that is omega. So its multiple will be 1 plus omega square plus omega. So this will also be 0. So see, coefficients whose subscripts are not equal to 3 will become 0. Now we know that is the case. Now we put x is equal to 1 here. So this will become 0, right? 1 plus 1 minus 2. Now we put omega. So 1 plus omega minus 2 omega square. So 1 plus omega is equal to minus omega square. So it becomes minus 3 omega square. So omega square to the power 6 will be 12, which is 1. And 3 to the power 6 we have to compute. Let me see how much that becomes. 3 to the power 6. So 3 3 ja 9, 3 ja 27. So that becomes 729. So that's how you can compute it very fast. And similarly for omega square, it will be 1 plus omega square, that is minus omega, and this will be minus 2x power 2, that is minus 3 omega to the power 6. So that's how we compute, and we will get the result. Though I don't think this is correct. Okay. The reason is this side you are looking at 2 times 729. Okay. And you add it 3 times. So you'll get a multiple of 3. So 243 times 2 would be 486. I don't think this is correct. This 31 looks like wrong to me. You do it and let me know in comments what is this correct value of the sum. Okay. Now we move on to question 120. Find the sum of the rational terms of the expansion 2 plus fifth root of 3 to the power 10. So r plus 1th term in the given expansion is tr plus 1 is equal to 10cr 2 to the power 10 minus r upon 2, 3 to the power r upon 5. For rational term, r has to be multiple of 5 for 3. So this power should be multiple of 5. So r to the power 5, r to the power 5 should be 3. And 10 minus r upon 2 has to be multiple of 2. So in the given series, for the condition 0, 5 and 10, and for the second condition 0, 2, 4, 6, 8 and 10. So common values for r are 0 and 10. So sum of rational terms, then you compute by putting r is equal to 0 and 10, you get 41 as the answer. So there are certain mistakes, computation mistake. This is, I don't think it is correct. Okay, you let me know. The second calculation mistake is in this one. Because this won't be x to the power 6489. This should be more like, I don't know, maybe correct. Looks like wrong to me, but let me see. 2x to the power 2 when multiplied with x will be 3. And let's say we multiply it with 1 plus x to the power. We compute the square, okay? So when you compute the square, this minus 3x square will become 9x square, and x times x will be, sorry, x to the power 4, it will become 9x to the power 4. So when it is 2, it becomes maximum power is 4. So this should be at most 4,326. Okay. Now let's square this. So we will have terms containing 1 plus x squared plus x3 plus x4. So total terms would be how many? 5 terms. 1 x squared, x cubed and x4. So this is definitely wrong. It is not correct. You assume it is ar x to the power r. We don't care about this calculation actually. Or let it be dot dot dot. The calculation will be simple. Okay. So these are 2-3 typing mistakes or calculation mistakes I see. So take care of this one and this one. Okay. I'm sure that these are wrong. I will I'll just remove this from here and I'll compute and update this one. So now I'll show you my books. When you come to my website astrologer.org, download algebra, trigonometry and connectivity from second, third and fourth link. Note that when you download the PDF, they won't have dates, so you add the date from the link here. The reason I cannot put a link in the PDF is that when I update the PDF, all the existing link will become invalid. Okay, so it is not practically feasible. Also, there will be typing mistakes in the books, quite a lot of them, as you would have known by now. So be very careful when reading the book. Just don't copy and paste, write down. Also, if you, as I said, you want to ask questions, you can come to my website, punjika.astravoc.org. I don't know why it is slow. Okay. So you have tags here. You make a login. You need login to create the answer. Algebra, calculus, ordinate geometry, geometry, probability, trigonometry, and general mathematics tag is there. So you can use these tags to ask your questions. You will need to supply at least one tag to tag your question. So come and ask your question here, and I'll be more than happy to answer your question. How to ask questions is you need to know Markdown a bit. So you read this Markdown help and you will know how you can ask questions on this. Okay. So with this, I will end this video here and I'll see you in the next one tomorrow with 10 more problems of binomial expansion. Thanks a lot for watching the video and have a great day. Stay curious, keep learning, and most importantly, enjoy.